The experiment that we will be performing is a soil permeability test using a constant head tank. The purpose of this lab is to measure the permeability constant for various materials. Permeability is a very important quality to see how water moves through certain materials, and based on this, it can be used to determine which material is needed for the engineering design. We will be applying Darcy's law, which is an equation that calculates the permeability coefficient for a given material. We will be using a light and a dark colored sand as a test material, since they both work with a constant head tank. To start the setup, tare the scale and acquire around 1,000 grams of material. Grab the number 200 sieve and bronze tray and cap. Insert the 1,000 grams of material on top of the sieve and put the cap on that. Bring this over to the rotary lab sifter. Put it on the bottom and set the timer at the top for 5 minutes and tilt the machine back when done and press enter. Once the 5 minutes is up, remove the sieve. Take this over to the scale and weigh out all the material that passed through to the copper tray. Record this mass for later. You will need this to calculate the mass of the material in the testing apparatus. Find the porous stones labeled with a B. This will be placed in the bottom of the test apparatus. Place a cylindrical part in the base and ensure that the stone is flat on the bottom. Then you will attach the two tubes, the outlet to the manometer. Next, we are going to fill the material in the apparatus. We are going to do this in a step called lifts. We are going to first fill it up right above the first manometer opening, and then compact it down with the 3D printed part. For the next lift, we are going to fill it to right underneath the manometer opening and compact this down again with the 3D printed part. For the final lift, we are going to use the rest of the material and put the 3D printed part and compact it down once again. Find the porous stone labeled with the T. Use your digital calipers to measure the height of the stone and record the height. Place the stone on top of the material. For the virtual lab, we will not need the height of the porous stone, so we will actually be recording the diameter of the porous stone, which will be on the screen in a few seconds. Use the 3D printed part to compact once again. Find the black ring and put it on appropriately. Then screw on the silver nuts to hold the ring in place. Place the top of the apparatus on the lid and screw in the caps. We must ensure there is a tight connection here. Make sure each of the valves on the apparatus are closed. Closed is perpendicular to the flow. Connect the tube from the head tank to the top of the apparatus. Connect the inlet of the head tank to the head of the sink. Turn the sink on. You don't need to turn it that much to get a good flow. Do not let the head tank overfill. Next, we are going to saturate the material. First, open the drain valve on the apparatus. Then open the top valve. Once you see all the material is saturated, shut the top valve off. Open the valve to the manometer, leaving only the top valve closed. Once both these valves are open, you can open the top valve once again and allow flow to pass through. Have one person in your group record the head difference in the manometer tubes. You can have another person record the flow discharge from the bottom of the apparatus. Record the length of the testing region. Also record the length between manometer valves. With the water turned off from the sink and the head tank empty, remove the tubes from the top of the apparatus and unscrew the top. Take off the nuts and remove the tubing from the apparatus to the manometer. Now we can remove the black ring from the testing apparatus. Once the black ring is removed, flip the cylinder upside down and remove the top porous stone. You could then tip the cylinder upside down and dump the rest of the sand out in the drying pan. Best sandcastle wins. Then we can use a 3D printed part to remove the bottom porous stone. Finally, you're going to want to rinse out the rest of the material from the cylinder. Once the cylinder is clean, dry it, and then you can prepare for your next test run.